The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Okay, next we're going to hear from one of my good friends, Kevin McDonald. If you start looking around for legal cases in concrete construction, which I happen to wrote a book on, you find a number of cases on responsibility for mixed design.
Yes.
And that's what Kevin's going to talk about.
Correct. And usually people say, Kevin, I hate going on after you because it's so hard. You have so many nice jokes. And I've never understood that until just now. So that's going to be very difficult for me because I have a Canadian accent and not a New York one. But I will fill in and I will give the Canadian experience. The Canadian experience for transportation structures designed for the Ministry of Transportation, Ontario. And do we have anybody here from Ontario in the room? Raise their hand and confess, right? That process should have sounded very familiar. That's precisely how it's done. And in fact, the last point that Kaz made, that there are lots of labs that don't do those tests. There is a certification process whereby the labs have to. But I'm going to tell you a terrible story. Many of us are licensed design professionals, which I think is the preferred ACI term. And in the Professional Engineers Journal, Engineering Dimensions, Professional Engineers of Ontario, there is in the blue pages, which is where the bad people are, a discussion of someone who was fabricating or correcting, in their terms, the results of air void analyses, because they don't measure the air at the end of the chute. They don't care. They measure the air because they buy hardened concrete, so they look under the microscope, and they have certified labs that do that testing, and there's a tolerance and everything else. And the report was that the lab's polishing equipment was broken, and therefore they couldn't polish the samples properly. And so those of you who have had the misfortune of running the test, you count the number of angels that dance on the head of a pin, and each row you count so many angels. And then she would correct each line and say, well, I only saw 23 angels, but there would have been 30 if I'd polished it properly. And the reason that they caught it was statistical variation. Instead of being a normal distribution, it was a chi-squared distribution where everything at the top end looked like a normal distribution and everything at the bottom end abruptly dropped, and there were no failures. So you have to be careful as well. So not only is the problem, are the tests capable of it, are the people really capable of it? Now, they only suspended this young lady's license for a year. Had that been compressive strength, I suspect they would have suspended it forever, because they would have realized, the terrible life safety of having a compressive strength problem. I have many times said as well, I've never seen a structure that has had major problems with freezing and thawing, but the whole reason I'm standing before you is because chloride ions move through concrete. I studied chemical engineering, which seemed to be the thing to do at the time because I liked chemistry, and I got a job inspecting bridges for a company that had a contract with the Ministry of Transportation, and lo and behold, found out that bridges don't fall down because they are not properly built. They fall down because they don't resist properly the environmental loads that they're achieving. So, why are we all here today? The system is very straightforward. We have a very good system of specifications. A specification is prepared which lays out all of the requirements for the project, and that's prepared by somebody. We'll get on to that who in a moment. And a submittal is prepared by someone who is complying with the specification. That may be the general contractor, a specialty contractor. In my particular case, although I'm no longer in the ready-mix industry, immediately I still play someone who's in the ready-mix industry on TV, and so I get to these submittals, and then we submit them, and the engineer signs off and says, I approve, these look perfect, and this is exactly what I intended, so everyone will be happy. And then a testing lab is hired, and they check off the box that says what was submitted was what was supplied. As a result, there's never any problems, and everything goes great, right? That's why Jeff doesn't have anything to eat, and that's why we're all sitting here at 9:20 on a Sunday afternoon. I say afternoon because if I say Sunday evening, I'll fall asleep. So there's no problems, and that's not really the case, right? I mean, concrete construction's been going on for thousands of years, and this, with all due apologies to Ken Hover, is a frieze from Trajan's Column. They're building a bridge over the Danube in 79 BC, and you can see it's a very auspicious day that we have the fellows over here. They're placing concrete. You can see they're ramming it into place, because when they said no slump, they meant no slump. Labor was somewhat free. These fellows here, he's a load is returning to the truck or to the plant for another load of concrete. Here's a load being distributed from the batch plant. This fellow is getting ready to build the false work, and it's an auspicious day. The contract, or the designer and the owner are there. They're making sure not to watch, because even they know that they might not be getting exactly what they want. For those of you who may be a little bit interested, Blood is an excellent Aaron training agent, and so I'm sure that if they found someone who wasn't meeting the specification, that's why some of those Roman structures are still there, because for that reason they're somewhat Aaron trained. And I went to a presentation at an ACI conference that I don't remember where, and I learned something very interesting. Brian Mathis said concrete only fails for two reasons. It either fails because you didn't follow the specification, or because the specification was wrong. That was an education for me, because I had only seen didn't follow the specification. I didn't realize that the specification could be wrong. It was a very interesting piece of information. And in fact, the Supreme Court agrees with me, right? The Sperrin decision in 1918 said, if I, as the ready-mix producer, contractor, whoever else, follow the specification, I, by definition, get what the owner wanted. And if I don't get what the owner wanted, and I can demonstrate that I followed the specification, then it's not my fault. Many, many times I said that. Right after I asked the salesman, where's the specification? And he said, no, this is one of those buildings where there isn't a specification. They just needed 4,000. So I gave them this document. And I said, really, it says here in this document that I found that claims purports to be the specification that we're supposed to have a water cement ratio of 0.32. Yeah, well, we didn't want to do that. That sounded hard, so we decided not to submit that. So I said, well, now we're going to go to a talk first meeting, because if we don't talk first, and we didn't always bring our lawyer, but certainly the talk first meeting of we may not have submitted or delivered exactly what met the specification became a problem. So I put up a couple of definitions. Those of you, there's at least two other TAC members in the room that I've seen, and there could be more than that. The dam in TAC is understood, not said out loud. So I thought we would talk about some definitions, and those two definitions are proportioning and designing. And proportioning is like to adjust to meet some recipe, and designing is to use forethought, the act of making designs. These are all definitions I found on the internet, but not in the concrete terminology, only because I didn't look there. Now, for fear that, but Pericles, you can tell me if there's one in there later on. We'll form a subcommittee. So we have proportioning, and many of us use the words mixed design, and many of us may realize that the CT does recommend we say mixture proportions, because often we're not designing the mixture. We don't set any of its properties. We're proportioning them to meet something else. So that starts to be where we're going down a slippery slope now, right? Because the ready-mix producer has at least two masters. Those two masters are the owner, who has a written document. He also has other unwritten owner requirements, typically. And some of those are, I wanted shrinkage, curling, appearance, cracking, longevity, right? How long does a building last? It'll last forever. If it doesn't last forever, it must have gotten bad concrete. And of course, we know that's not the case. And then I was involved in a project not too far from here where the specification said, and I quote, the building shall be designed to have a 100-year service life, period. And they went on to talk about something else. I don't know what that meant. But I do know that the contractor was very good. They said, Kevin, you can figure that out for us, right? And you'll tell us that your concrete will have a 100-year design life. Which of course we said, how the heck can we do that? It doesn't make an awful lot of sense. We go on and look at this process. If the ready-mix producer is being held responsible for a 100-year design life, guess what I have to control? I have to control, for chloride ion corrosion, two things: the permeability of the concrete and the clear cover. Because if I have very impermeable concrete and the steel is only up a quarter of an inch below it, I probably won't get what I want. Now, Ontario had a specification for a long time, but present within limits for bridge decks on clear cover to reinforcement. And that clear cover to reinforcement was a one-tailed failure. You could be too low, it could be too close to the steel, but it was never set up to be too far. So guess what? If 2 inches of cover was good, 6 inches of cover was great. If you calculated the additional concrete that you had to put in versus what you got out of the additional bonus, you were golden anyways, and away you go. So that became a two-tailed failure. So these processes have to evolve. You have to understand what it is that you're getting. But he has another master. And this master is a different one than the owner. I have a poster that says, hard work might pay off in the future, but procrastination always pays off right now. Meeting the owner's requirements might be good, but meeting the installer's requirements is always good because you send him an invoice. Eventually, the owner may be upset, but you sent the invoice to the guy who's finishing the concrete, and if it doesn't meet his requirements, workability, finishability, setting characteristics, expected to strip it, hot and cold weather, as I said earlier today, you need to get home so you can make some more fly ash for tomorrow's placement by running your oven at the peak time. Those requirements are equally important. And the problem is we start to get into conflict. Now you can laugh, but this guy read the specification. It said water shall not be added to the drum after batching. No problem. If we don't have an understanding of why it is that we're doing things, we will make one of those masters very happy. It's very easy. It's very difficult in the ready mix industry to turn to the salesman, to turn to the senior management and say, we have to do this even though the customer doesn't like it. Right? What's the great adage? The customer's always right. It's really good to say, well, the customer's always right, but in this particular case, he's totally wrong. So where do we go? It's easy. Performance-based specifications, right? We've known about them forever. Here's what I want. Your concrete should pour like Niagara and have the strength of Gibraltar. That's the Canadian experience, right? Two Commonwealth references. When that was drawn, you remember, Colin, when we used to wear those five-pointed hats? We still scratch our heads a lot, but we don't wear the five-pointed heads a lot. This was not really possible, right? You could make pour like Niagara concrete. It wouldn't have the strength of Gibraltar. It might have the cracks of Gibraltar. Similarly, if you wanted high strength, you got those sticks out that the Roman guys had and you pounded the concrete in place. We've gone away from that, and that leads us to a problem as well, because once upon a time, for a given set of concrete mixture proportions, if you added additional water, the slump went up. Now, it doesn't matter. Slump's very useful if you're making concrete, because if you think you're doing the same thing and you take a slump and then you run another batch, right? That's how concrete's made, like cookies in small batches by elves and trees. If you check that second batch and the slump is different, you didn't do the same thing. You might be aware you didn't do the same thing, or you might be finding out you didn't do the same thing. So very useful quality control tool, absolutely useless quality assurance testing. And I think this is the point Kaz was trying to make. You can run into a problem. If I say that you can trust me because I know that my concrete will last for 100 years, and you're foolish enough to just take my word for it, which gets to Julie's point, you can run into trouble. Now, in 100 years, even I probably won't be alive. I'm about 12, so I plan on living that long. But in case I don't, 100 years is a long time. Who's really going to remember, right? So, as long as I don't have to put it in writing, we're all golden. But that's not what happens. So let's see how simple we are for testing. This is a pretty straightforward specification. But it's something that I often have to remind people. A test is the average of 2 cylinders, not the 1 cylinder you decided to break. And the strength is specified, over a performance basis, to be the 3 sets of 2 cylinders, not the cylinder you broke yesterday. No individual set more than 500 psi low. Sounds like a pretty straightforward process, but this might not be enough if what you're trying to do is control things. I'm dealing with a project right now where the specification says the concrete shall be 3,000 psi plus or minus 25%. I can design the mixture. I just designed it to be 3,000 bang on. And then I say, you run your plant. So your standard deviation, I got my little abacus out. I didn't use a slide rule. I used an abacus and said, yeah, have your standard deviation, set the dial on the plant to 400. You'll be fine. How do you do that? I don't know. I didn't write the specification either. I don't think it's constructible. I said, that's where you should start. And they said, oh no, it's too late. We signed the contract. So you have to be careful about that as well. But here's the real interesting problem. This is a slide, apologies to the Brown Intertech people in the room. The Brown Intertech cast a bunch of samples years ago, Greg. You were probably in the grade school for a very large research project, and they couldn't figure out why there was so much variability in all of the data they were getting. And then I dug through the archives, because I was working for Brown at the time, but was not at the time the samples were cast, and lo and behold, this is why. Those cylinders are not representative of what's in situ, because they're getting a little bit warm, and the best way, of course, to get them warm is to put them in black molds here. But if you can't do that and you want them to stay warm all night, put some aggregate up there to retain the heat. I mean, it's so that we do have some problems, and here's a testing I have a great deal of respect for, that could happen to anyone. In fact, it never happened to Semstone because, of course, we never had to report our results to anyone. Then we have a good specification, right? Slump limits. This is my favorite one. This is a specification that says the slump limit is going to be 2 to 3 inches before you add whatever the high range is, and no more than 8 inches after. It's pretty reasonable, except the accuracy of batching in a plant versus the accuracy of batching in the field is so different that you don't ever want to be adding admixture to the plate. That's requiring you to do one of two things: pump 2 to 3 inch concrete slump, which seems silly to me, or verify its slump, add the high range water reducing admixture, then don't look at the air again. The air is going to change because the workability is going to change. This becomes a problem. So why can't you just say the slump should be what's required? In fact, when I write specifications, which I do from time to time, and I have my druthers and start with a blank page, I say the slump shall be suitable for the intended construction method without segregation, which I define because I can't remember the STM number, but there's a nice one for shrinkage or for self-consolidating concrete, and so I say visual stability index as measured by this method of 1 or less, which you can do on a regular slump cone. At a 10-inch slump, you will have a pretty good VSI. If it's not segregating, if you haven't interfered with the water to cement ratio, you're fine. If you have, you can get by with strength. My favorite test method to measure is the resistivity of the concrete at exactly 24 hours, because that you can relate to the RCP at 90 days if you get a correlation. I spent a lot of time in Toronto, and I had the great fortune of working with John Bickley and my father for a very short period of time. My father couldn't stand me, and John Bickley went off to do something else. But in both cases, I learned from there that 7 days is too long to know whether you have made the right concrete. You need a test, it's an index test at 24 hours if you're making it, because you can make a lot of concrete if you're paving JFK. How do you know that 120 days from now you're not going to get the, hey, you're getting 50%? Bill, you need to know when you're making it. And sometimes you don't have the, when you're making 200 cubic yards of concrete an hour, you can figure out what that is in pounds per minute. It's very high. You are making concrete to an acceptable standard, and you have good people and good equipment, you still have some variability. Things do go wrong. You need a system that catches them. Most high-range water admixtures, reducing admixtures, shouldn't be site added. And why have an 8-inch maximum slump when we know that we can make a 25-inch spread on the ground that has an RCP at 90 days of 100 coulombs passed? It's fantastic material. What's the compressive strength? I don't know. I don't measure it either, because it wasn't a design criteria for me. Who knows what workability is best? Most of you who are designers in the room will know that what's the one thing you should stay away from? Means and methods, right? Never one of you says, it says on a regular basis, you look in there, you give your daily affirmation in the mirror and says, I will not prescribe means and methods. But if you set the slump to 2 to 3 inches, you sure as hell have set means and methods. Some of those concretes may not be pumpable, or worse, I might make them pumpable at a 2 to 3 inch slump. And then if I do that, I'm going to do lots of things that are going to cause cracking. Is the contractor going to be building like this? I don't know what's out in the distance, but it's much more interesting than the bucket apparently. Or are they going to be doing this? Two different concretes could meet the same specification but are being placed differently. Stay away from slump. It's a means and methods. This is the silliest device for measuring the quality of concrete. Very useful for measuring whether you are making the same batch or not. We covered that already, right? Segregation, that's what it looks like. it's pretty ugly, it's pretty straightforward, and if you get segregation, then you know it's occurring. You can see it in the hardened state, you can see it in the plastic state. This is a pavement here, section that was taken from the trunk highway in Ottawa, Ontario. I used to get 2 days of vacation a year in Canada. That's the other Canadian experience, because the weather looks like it does outside, so why would you want to be outside? You may as well go to work. And as a consequence, I was off this day, and they took these cores. And they took the cores because there was the proverbial water valve had stuck on. I still don't know where that water valve is on the truck, and I can't find it. But what it usually means is there was a couple of 100 gallons of water in the load when it presented itself at the batch plant. And you can see up here, these are cracks, and it's very badly cracked. And it's very nice. It's a very good example if you're teaching people about mixture proportioning, because you can see here's the big rocks and the little rocks and the sorts of little rocks. It's really nicely segregated itself off, but because I was out of town and they didn't notice they tear it out, they cut it here and they broke it, and it met the compressive strength requirement. So then they called me and said, what the hell do we do? It meets the compressive strength requirement. I said, can you still scratch the surface with your fingernail? 7 days old. Yes. So then you should tear it out. What do you think is going to happen when you put trucks with studded tires across it? It's going to be a problem. Compressive strength, a very bad number. So you write a specification and you hand it to me, the ready mix supplier, and it says the compressive strength required is 3,500 psi, and you want a 0.40 water to cement ratio. Now, which one do you want? And here's where you really fall into a trap, because if you measure strength and all the strengths are 4,500 or 4,000, you're going to be really happy, because I'm way over the specification. In fact, I probably never missed that specification, but you probably don't have a 0.40 water to cement ratio. In fact, I pretty much guarantee you can't, because if you follow this specification and you look at it as a reasonable producer, you say, I'm going to design my mixture to meet the more stringent of those two requirements, I'm going to have 6,500 psi. If you go outside and walk a block from the hotel, you can see Target's headquarters. And so the Target people call me up and say, we don't like using your concrete. So why not? So, well, the strength is really, really high. Yeah? It's like 6,000 or 7,000 psi, 28 days. Yeah. Well, it's specified to be 3,500. It sure is. And it's specified to be a 0.40 water to cement ratio. And since the 0.40 gives me 7,000, what do you want? Well, I want a 0.40, 3,500 psi concrete. That's what I specified. I said, you can write anything down that you want, but I can't do what isn't physically possible. And I could lie to you and get you low strengths and you'd be all happy, but then when it curls and shrinks and cracks, I'm going to be back, because that guy, that second master of mine, that'll happen before substantial completion. So before substantial completion, when they have his money, he has mine. Almost on purpose. Right? Several weeks after substantial completion, months, years. So you do end up with a situation where the supplier here has an ethical dilemma. Do I meet the strength? Do I meet the water to cement ratio? Because water cement ratio and strength aren't connected. Just change the cement content at a fixed water cement ratio, increase the water content, increase the cement content, you get higher strength. Right? Abrams said, all other things being equal, water to cement controls the strength. We sometimes forget the all other things being equal. Here's a couple of concretes. Both of them have a 0.40 water to cement ratio. The 600-pound, 240-pound of water mixture, that's going to shrink a lot less. Strengths will be same or similar, maybe a little bit higher for the second one. The permeability is going to be higher. Permeability is going to be higher at a fixed water to cement ratio, because most of the permeability occurs in the paste fraction, and you've got lots of it in this mixture. And then we get to the other perennial favorite. This is the Wakota Bridge, for those Minnesotans in the room, under construction, and we're pumping the concrete from the far shore of the Mississippi, about 500 feet out, across a very, very sad and angry bunch of people. So let me ask you a question. Do you measure the slump here? Or do you measure it there? Or do you measure it where it's coming out of the truck? The specification doesn't say. So the owner says, well, I like them to meet in all places. I said, that's really good. I do too. I like to be 6 feet tall. Well, that only happens when I'm not awake. Now, if I make it past here, it's going to be higher than is allowed here. Okay, but you want to test it here, and then you want to send somebody out and test it there. Plus, you've got 4 guys with slump cones, and they all want to meet the same requirements. What you really should do, and I had this long discussion with the new incoming head head of the Department of Transportation, you don't buy plastic concrete, so stop testing it. You buy hardened concrete. Let me decide what is best suited for making that hardened concrete. You set criteria that we're going to match, and then we'll go along with that criteria. We got lots of finishing problems, and they come from all sorts of other places. And then we have this discussion. I had these slides prepared before the responsibility meeting, but this is an issue that occurs very much, and the fellow left holding the bag, unless he can blame it on his material suppliers, is the ready mix operator. Because you say, well, your concrete has a pH of 12.5, and I said, that's because I put the Portland cement in that you specify. So you end up with this situation, who's to blame here? We need to have much better performance criteria, because rarely in the ready mix industry when we deal with authority are we this successful. So who should the designer be responsible for, right? The designer should be responsible for performance. The problem we don't know right now is who's the designer. The designer has control, right? If her design doesn't work, that's where the fault lies. Unless the construction team failed to follow the instructions. That's what Brian Mather told me in a presentation that I heard over 25 years ago. But if the designer is giving you such tight control over the mixture proportion that it's very prescriptive, if it doesn't meet what the owner wants, it's the designer of the specification of the building, a licensed design professional, who's at fault. If it's performance, and I can't spell performance no matter how hard I try, you end up having a problem. That's a performance issue I have. But worse, we live in the world of the common specification, which is both and neither. So let's look at a prescriptive specification. And if you look at the back of the document, those of you who got them, you'll see that there is some discussion of prescriptive and performance specifications. And if you have written a prescriptive specification that says, I need this much cement and this much water, and even if you have said I can choose the aggregate particles, I really can't make much of a difference because you've told me the maximum size and conform to C33, not a lot of freedom, then if I supply the concrete in accordance with the prescribed requirement, and you should conduct appropriate and sufficient quality control to see if in fact you have, or I should be able to demonstrate to you that I in fact have made what you said, then it's your fault. You have taken on that responsibility, and it is unfair for you to come as the designer or the contractor and say your concrete didn't perform because it's not my concrete. I proportioned it to your recipe. That becomes a problem. In a performance-based specification, which is where we should go, you know that you can use laboratory permeability. You can really be really nerdy like me, and you can use a diffusion coefficient. You can calculate the rate at which chlorides will go in. You can run a Monte Carlo simulation in Las Vegas for the and it's a true story, for the I-35W bridge. I did it while in my hotel room at the World of Concrete. It's a Monte Carlo simulation to attempt to see how much risk I was taking on. And say you want a 100-year design life. I don't recommend it as a specification because it's kind of confusing. But you can look and say, if I have this concrete, which I think I can get these properties for, and they'll meet your structural requirements, but you need to have 4 inches of clear cover in order to get there, and we have to get the concrete not to crack, which means a design issue and a materials issue. Then under the direction of the owner, some quality assurance and reviewing quality assurance reports goes on, or both, to ascertain on the owner's behalf that the performance criteria has been met. Then the concrete supplier should be responsible for that. And in order to be responsible for that, he has to work hand in glove with the installer, which is a terrible thing because all that would do is promote communication. Jeff, again, would have nothing to do, and we'd all be in rough shape. Now, since, as I said, custody transfers at least a couple of times, so curing needs to be important. In Ontario, they're going to propose, they're no longer going to cast cylinders at all. They're going to go to this bridge deck, they're going to core out cores, they're going to break them, and that's going to be the criteria because they buy hardened, not plastic concrete. That will become a major issue between the supplier and the contractor, who should be talking anyway. But sometimes that doesn't happen. And the problem we have with the common alternative, which is probably most of the specifications here in the United States, is that there's a lack of clarity in roles and responsibilities, and that the rate of change in concrete technology is happening so fast that it makes sustainability seem to be steady. As long as this is the kind of concrete that we want, this is a 6-act mixture, I counted the bags, then this is then the common specification is where we should go. So I will turn things over. I'm sure I'm over my time, but that happens from time to time. Thank you.